I was so happy when I finished working on my first iOS project 6 years ago. The app ran smoothly, and I was really proud about the code base. So I decided to do something stupid. Oh. That's me being happy. I decided to do something stupid. I wanted to show off my code to a senior developer. And we started looking at it, and senior developer got puzzled, but I had explanations and reasons behind every my decision. Though the deeper we went into the code base, the worse it got. We reached such a place where we realized that in order to keep the code base maintainable, we had to break most of it apart. It took me one more hard week just to get the project to compile. Ever since then, I am thinking about what code do I want to write? What code do I want other people to write? What is a really good code, and what code you would deserve a medal for? And Stack Overflow has a lot of opinions about good code. But actually, their co-founder, Jeff Atwood, gave a really great explanation of such code. He said, "It is painful for most software developers to acknowledge this, because they love code so much." And we do. But the best code is no code at all. Every new line of code every new line of code we willingly bring into the world is code that has to be debugged, code that has to be supported, and code that has to be read and understood. So this idea of the best code being no code at all inspired most of this talk. So let's quickly overview it. We'll start off by looking at a problem. Where does most of our code end up and become a messy spaghetti? Then we'll dream a little bit and think of the perfect solution, what we wish we are there when now we have spaghetti. Having a dream in mind, we'll continue on with something that would actually work, something real, given the environment that we are working on. And lastly, we'll try to push the solution so that using it requires as little code as possible. So as you can see, this talk is perfectly fitted for you before lunch, because it's a lightweight talk. Let's get into spaghetti. Sorry for, And where does most of our code end up at? We like it or not, most of the time, it ends up at the Viewcontroller. And a lot of bad things can happen there. But one thing, at least to me, always happens. My Viewcontroller gets tangled up with other Viewcontrollers, with its parents, navigation controllers, tab bars. It decides on its own presentation style. Do I want to be in a modal? It dictates navigation flow. Show this, present that. Hey, navigation, show this. And if you're using Storyboard and prepare for segue method, you will have to arrange the next Viewcontroller and perfectly know all of its details. And that makes it really hard for us to reason about an individual Viewcontroller. It makes it hard for us to test it, and it makes it really hard for us to replace it. So what if Viewcontrollers didn't care about any of this? What if they didn't care what are their parents? What if they didn't care what and how they can present themselves? Let's get to the first part of this talk, the interesting part, and it is dreaming about a solution. So, are you dreaming about a solution, having your perfect Viewcontrollers? All right, I'll help a bit. I think when dreaming about a solution, we have to dream big. We have to forget all limitations, all the preconditions that we had before. And this is true no matter the problem. We can be thinking about something as difficult as networking or encryption or storage, or something as trivial as cell reuse, typefaces, or a color palette. We have to dream big because most of the time we will end up short. and we want that short to be as good as possible. It will be way better than what we have right now, right? So, in this talk, I invite you to dream with me about view controller isolation from other view controllers. So let's imagine that this gray square over here is a perfectly isolated view controller. It knows nothing about the rest of the view controllers in your application. It is totally contained. Well, it turns out that you cannot do this because your view controller needs some kind of initial data for this setup. So we can add a hole to represent the input that our view controller requires. And in our dream scenario, if we wish to express it in Swift, we could say that our view controller that has input requiring protocol adoption which simply needs to express the type that it wishes to get. And that would be enough from the view controller side. And then, hopefully, someone, maybe you, maybe Apple, maybe someone else, I don't know, would magically give us superpower, like an input that we could use anytime we want. And it would be the input of the exact type that we wish to have. We don't care where it came from. Right. This keeps our view controller simple and nice. But when we have created it, something else happens. At some point, our view controller has some kind of information that it doesn't really need itself. It is an information that it wants to produce and give to another screen. So we can add a knob to represent the output that our view controller can produce. Again, in Swift, in the dream world, we would simply adopt output producing protocol, declare the type that we wish to produce, the output type, and again, someone would magically give us superpowers and a function that we could call anytime we wish to produce the output value. And this is really nice and simple, but there's one more thing that could happen. Your view controller at some point might want to be informed about some kind of change while it was not on screen. So we can add another hole at the top to represent the update that our view controller is interested in handling. Again, in Swift, a simple protocol adoption would do it. We would write a function to handle the update type that we're really interested in. And of course, most of the time, your view controllers will be able to produce more than one output and will be able to handle more than one update. We can think about this case being solved by an enum with associated types. And that's it. That's all the communication that our view controller really needs to have with the rest of the view controllers. It needs to have an input it requires, the output that it can produce, and an update that it can possibly handle. Such view controller is like a puzzle piece. It knows nothing about the big picture, though is a small and an essential part of it. All right. This is the dream that we will keep in mind for this talk. This is what we're striving for. View controller isolation. But enough dreaming. We can't just isolate view controllers. Transitions need to happen. Data needs to be propagated. Who will do all the work? Well, keeping the dream in mind, let's get to the next section of this talk, and it is thinking about something that actually would work. And other people had really great ideas about connecting such isolated view controllers. You might have heard of them being called flow coordinators, routers, or just navigators. But there's one problem with them. Even though this is a really nice coordinator that I think is a great representation of a compact and simple coordinator, but it was a couple of hundred lines of code just to express the possible flow in a simple app. What we are striving here is something that requires less code. So in this talk, I'll try to work out with you a solution that would solve our problem, that would solve our puzzle. And I will call it a puzzle solver. So a puzzle solver simply connects your view controllers, it makes the transition happen, and it propagates the data between them. So to solve a puzzle, it turns out you need two things. First, you need to know the big picture. You need to know what are you building. You need to know which two pieces fit together. Or in other words, you need to know what transitions can happen from the current view controller. And when I say a transition, I simply mean a structure of information that answers two questions. Where from and where to is the transition happening, and how do you go from one screen to the next one? What's the style of it? And that's it. Our instructions, the big picture, and the puzzle solver is simply an array of all available transitions that can happen. Once we have all of the available transition, we have to do something next. We actually need to be able to pick the right transition at the right time. We need to be able to pick the right puzzle piece to fit with the one that we currently have. So, for a given output, we need to decide what transition do we want to perform. And here's something really interesting. If we have our view controllers declared like perfect puzzle pieces, where the output produced by one view controller perfectly matches the input of another view controller, then this is really simple. To find the right transition, we can simply return, what I'm talking about, sorry. I went ahead a bit in front of me. Remember then that to solve a puzzle, you just really need some instructions, and you need to be able to find the right transition. We'll get back how to find the right transition in a little bit, even though now you have an idea how to do it. Right, so that was the general idea of the puzzle solver. To solve a puzzle, you need the instructions, and you need to be able to find the right piece and the right transition. And before we start implementing, before we do any of this that I already told you a bit about, we have to remember what Jeff Atwood told us at the very beginning of this talk. The best code is no code at all. So how can we implement the puzzle solver so that using it from our application requires as little code as possible? So now let's look at each piece individually. And I already told you something about finding the right transition. So to find the right transition, if your view controllers match perfectly, we can simply return the first transition that the destination's input matches the output that we just received. And if you look at the code really closely, it is not an exactly right code, but it brings the general idea with it. So we can use type checking to find the right transition for us. And this is such a good solution because it generalizes the problem. We don't need to write any code by ourselves to decide where do we want to go. And such solution, I believe, as I stated in the beginning, deserves a medal. We need to do no work for this to work. No work to work. That's nice. So we have a really nice start. Half of our puzzle solver doesn't need any code of our own. So for the rest of this talk, we'll focus on a bit more complicated part of this, about the big picture, about all of the possible transitions, and about the navigation flow in your application. Do you already have any ideas how we could do this? Well, before we jump into those, let's just remember, a transition knows where from, where to, and how is it happening. So to better understand this, let's put it in a context of some actual view controllers. Let's say that A, B, C, and D are subclasses of a view controller in our application. And they have their input types declared, something that they require to work. They have the outputs that they can produce declared as well. And A even has an update that it can handle. So now to answer the question, where from and where to can our app go? Where from and where to can a transition happen? We can simply link the loose ends. Now this diagram answers this question. It's obvious that you can go from A to B, from B to C, and you can go back from C to A. And there's D over there in the corner as well that you can reach. How would we answer the question of the style of the transition in this diagram? Well, we could simply use different colors. Let's use a green one for a push, a pink color for modal presentation, and a blue color representing going back in the navigation stack. So this diagram represents something that we want to express using as little code as possible. This diagram represents the transitions in our application flow. So let's start off writing as little code as we can. So we can say A can show B and present D. B can then show C and present D. And C can unwind back to A. And this is enough code to describe what we want. It answers the question where from, where to, and how the transition is happening. Unfortunately, this is not a valid Swift syntax, so we need to add a little bit more code. A, B, C, and D are actually Viewcontroller subclasses. And when we are constructing this flow, we don't want to use instances of Viewcontrollers. We want to use their types. So let's use the .self syntax to get the type of the Viewcontroller. The top A, on the other hand, is the initial Viewcontroller of your application, or any other Viewcontroller really that you want to describe the flow from. So we would simply assign this flow to an instance of A. And as you can see, flow is simply an array of available transitions from a single Viewcontroller. At this point, we're only missing a few punctuation marks. That's it. This code compiles, it works, and it answers the question where from, where to, and how the transition is happening. So we can use simple and nice Swift code to describe the big picture, the instructions part of our puzzle solver. And if we use our Viewcontrollers as a puzzle pieces where they have their inputs, outputs, and updates declared, this is all that we need. But we can do even better. You might have noticed that the instructions diagram that we had before is really similar to something. Can you guess it? Of course, it's the storyboard. The storyboard is meant to represent the navigation flow of your app. It shows that you can push from A to B and from B to C, and that D can be presented modally from both A and B. Of course, we cannot see unwind segues, but they're over here in the sidebar. Storyboards are meant to answer the question where from, where to, and how do you want to go. If we could extract this information, storyboard segues actually would represent the navigation flow of our app. It would be the instructions to our puzzle solver for it to be solved. What this means, it means that we can use either really nice and compact Swift code or a visual approach with the storyboard segues to represent our application flow. Actually, those two are perfectly compatible. It means that we can mix and match them in our application based on the problem that we have at one corner or the other. But there's one more thing. To to solve a puzzle, you don't really need any instructions, do you? You can simply check each puzzle piece against the one that you currently have and see if they match. It means that you can check Viewcontroller inputs and output types with the input and update types with the output which was just produced, and answer the question where from and where to can we go in our app without writing any code at all. Swift's type check can do this for us as well. Well, what about the style of the transition? How do we go from one screen to the next one? Well, it turns out that UIKit's show method on a Viewcontroller picks the right transition style most of the time. So most of the time, we won't need to write any code to describe the style of the transition as well. It will show or present accordingly. We end up with Viewcontrollers that are like puzzle pieces. They are isolated, they are testable, and they are easily replaceable. And we can connect them in an application flow in any way we like, using nice and short Swift syntax, a visual storyboard, or doing nothing at all and letting Swift's type check to do the hard work for us. And if you remember, this was the dream that we wished. We wished that Viewcontrollers were isolated. We didn't wish to connect them. That's not the job that we want to do. We want to describe Viewcontrollers, and we want the connections happen automatically. So all of this dream, the details of it, and the implementation of it has actually been put in an open source project that we call Storyflow. It will be available on GitHub in upcoming few weeks. But just let's quickly peek inside of it. What does it contain? So, Storyflow helps you describe your Viewcontrollers as puzzle pieces. So you will have protocols for input requiring, output producing, and update handling Viewcontrollers. As well, it will give you the extension that we wished for. So input requiring Viewcontrollers will gain an input property that it can read from. Output producing Viewcontrollers will gain a functionality to actually produce the output that you want to produce. As well, for the puzzle part of your Viewcontroller, the Storyflow includes a nice generic enum that you can use to represent multiple outputs and to handle multiple updates. For the Swift description of your navigation flow, Storyflow contains functions to produce the transitions. It helps you write the syntax that you saw earlier in this talk. And it adds a flow variable to every output producing Viewcontroller. So any output producing Viewcontroller can actually have a flow coming out of it. For the storyboard part, getting the segues turned into the transitions and put inside the flow of an outputting Viewcontroller, Storyflow gives you a build step that you can add there to simply do that, turn your segues into transitions without you writing any code. And lastly, and probably most importantly, Storyflow includes a dynamic lookup for the next Viewcontroller, checking your Viewcontroller types and checking their inputs and outputs to decide which transition to do. So we wrote all of this code and bundled it up in a single open source project just because we could forget about it and not write it anymore. So 6 years ago, I started thinking about what code should I write, what is the best code, but most importantly, what code not to write. Thank you.
Thank you very much, Domas.
Thank you.